Let's find absolute max and min for the function 2 over x minus 1 on the interval from 0 to 4. 2 steps. We're going to find first any critical numbers. So we're going to take the derivative of this. Before we do that, we might need to rewrite this function. I don't want to have to use the quotient rule when taking this derivative, and there's only x's in the denominator. So I don't have to use the quotient rule since there's not x's in both the top and the bottom. So I'm going to rewrite this as 2 times x minus 1, and it's in the denominator, so it's to a negative 1 power. Negative because it's in the denominator, 1 power because the power is not written. So we're going to take the derivative now using the chain rule. I'm going to bring down the power. 2 times negative 1 is going to be negative 2. I'm going to keep the original inside and raise it to a new power. So I need to keep the x minus 1 and raise it to the negative 1 minus 1 is going to be negative 2. All times the derivative of the inside, derivative of 1x is 1, derivative of negative 1 is 0. So to solve this derivative, I need to put that negative exponent down in the bottom where it belongs. We just have negative 2 over x minus 1 squared. And that's because our constants were negative 2 times 1, which is just negative 2 in the top. And then that negative 2 power goes in the denominator as being squared. We're going to set this equal to 0. And we want to see what makes the top 0 and what makes the bottom 0. Well, the top is always going to be negative 2. So we're not going to make that 0. But the bottom, x minus 1, could equal 0 as long as x is positive 1. This makes f prime undefined, which it means it might not technically go into the original function. It might not be called a critical number, right? A critical number makes a derivative 0 or undefined, but it also has to go into the original function to be called a critical number, which we're going to find out in our second step. The second step says compare the endpoints on your interval to any critical number in between. So we're looking at the interval from 0 to 4. And is our critical number on that interval? Yes, 1 is on that interval. So we're going to test that to see its y value as well. And this is also where we'll figure out if it's technically called a critical number or not. Because if it has a y value, then it is a critical number, makes the derivative undefined, but goes into the original, and we get out a number 6 or something like that with no issue. But if we plug in and we get undefined in the original, then it was never technically called a critical number if it can't go into the original function. But we're just going to go ahead and plug in and see what absolute extrema we have. So plugging into the top, we have 2 over x is 0 minus 1. So we're going to get 2 divided by negative 1, which is negative 2. Plugging in 1 to the original function, we'd have 2 divided by 1 minus 1, which would give us 2 divided by 0. That gives you an error in your calculator. That is going to be undefined. And then lastly, plugging in 4, we're going to have 2 over 4 minus 1, which is going to be 2/3. I would normally leave it as a fraction, but I'm going to also write the approximate decimal value just because we're trying to figure out what's higher and what's lower. So this is about 0.67. So looking at our y values, we want to pick the absolute max value and the absolute min value. So we're picking between negative 2, undefined, and 2/3, which is about 0.67. So which one of those is the highest y value? Well, undefined isn't a y value, so I'm just picking what's higher, negative 2 or 2/3, and that is going to be 2/3. Because 0.6 is higher than negative 2. And then the absolute min value would be negative 2. So it turns out what made the derivative undefined, also made the original undefined, so it was never a critical number. That's a vertical asymptote on the graph. But on this interval where we're zooming in on between 0 and 4, negative 2 is the lowest y value and positive 2/3 is the highest y value. And you could also write those as points if it asked. You would write as a point, this would be 0, negative 2, and the other point would be 4, 2/3. So you will either be asked as a point or as just the value. If it asked the location of the max or min, you would just type in the x. X is location, value means y value, point means right both.